Hello, this is Andrea Hendricks, and I want to continue working for you problems from section 4.1 and really section 4.2 homework problems in my math lab. The first problem that we're going to talk about asks us to find the equation of the vertical asymptote of the graph of y is equal to 1 over x minus 2 plus 4, and also to find the horizontal asymptote. Well, so remember that the vertical asymptote is where the function is undefined. So that occurs where the denominator x minus 2 is equal to 0. So in this case that would be at x is equal to 2. The horizontal asymptote is what happens as a function, or as the values of x approach infinity, what's happening to the y values. Well, as x is going to infinity, remember that this value, 1 over x minus 2, is going to 0. So that means that the whole function is going to 0 plus 4 or 4. So the horizontal asymptote is y is equal to 4. And generally you're going to find that it is this constant to the right of that rational expression. Identify the graph with the range negative infinity to 4, union 4 to infinity. So this is the range. So really what that is saying is that we have a horizontal asymptote at y is equal to 4. Because everything is included except for 4. And you can see that that happens right here in the graph of C would be the answer. Now we're to graph the following function, 1 over x minus 3. Well, 1 over x minus 3 is a graph of 1 over x shifted right 3 units. So what that means is that our vertical asymptote has shifted right 3 units to become x is equal to 3. And our horizontal asymptote, to shift a horizontal line right 3 units, still stays in the same place, so it is y is equal to 0. So we're looking for a horizontal asymptote of 0, vertical asymptote at 3. And remember that the graph has a basic shape of down here, right, and then above the asymptote on the other side. So that shape just shifted right, and that occurs right here in part C. Okay. Now to graph this function, 1 over x plus 1, well, this is the graph of 1 over x shifted up 1 unit. So to shift up 1 unit means our vertical asymptote stays the same. It is at x equals 0. And again, that is the value of x that makes that expression undefined. The horizontal asymptote would go up 1 unit to become y is equal to 1. And again, that shape of down and then up is what we're looking for because there's no reflection there. So we're shifting up 1, and that looks like this graph right here. Okay. Number 6 says, which of the following best describes how the graph of f can be obtained from the graph of y equals 1 over x squared? So f of x is negative 5 over x squared. So remember that the negative 5 implies that there is a reflection across which axis? Do you remember? Okay, this is really taking the opposite of y, and the opposite of y occurs across the x-axis. And what about that factor of 5? What does it do? Right, it has a vertical stretch by the factor of 5. So which one satisfies that? That would be reflection over the x, vertical stretch by 5, so that would be B. Graph f of x is equal to 1 over x minus 3 squared. Okay, so this is the graph of 1 over x squared shifted right 3 units. So we've got to think about how our asymptotes are affected. So our vertical asymptote is again what makes the denominator 0, but we can see that from the shifting of it right 3. So the vertical asymptote is at x is equal to 3. The horizontal asymptote did not change in this shifting right, so it's still y is equal to 0. And then remember 1 over x squared has that basic shape of this. So we're looking for that basic shape just moved over 3 units to the right, and that would be B. explain how the graph of f can be obtained from the graph of y is equal to 1 over x. So our graph is negative 1 over x plus 1 plus 5. So we've got three changes going on. Got to think about that negative, the plus 1 in the denominator, and then the plus 5. So we know the plus 5 is going to make it go up 5. The plus 1 in the denominator is going to do left 1. And then we already talked about this negative before, I think. To take the opposite of y means that it's going to reflect across the x-axis. And so it says a graph of this can be obtained from 1 over x by reflecting it across the x-axis and shifting it how? Well, then we would need to do left 1 unit and up 5 unit. So that would be part C there. The graph of a rational function is shown. This is number 10. Identify the rational function. So, first of all, notice that since it is going in the same direction on each side of the asymptote, it has to be some variation of 1 over x squared. We know it's a reflection, so there's going to be a negative 1 over x squared. And then there's also a shift, right? It shifted, it looks like, to the right by 2 units. And so that means our denominator is going to be affected by shifting it right 2 units. So we should be looking for part B. Number 12, use long division to rewrite the rational expression and determine the shape of the graph. Honestly, this is not an outcome of the course, and this is my fault. Someone else had written these homework exercises and I just kept them in. But you really don't need to know how to do long division, but I'll show you just so you can get this problem right. To do long division of expressions, what you have to do is divide the first term of your divisor into this first term of the dividend. So we say x goes into 2x, how many times? Right, 2 times. So we would have a 2 there. And then we say 2 times x is 2x. 2 times negative 4 is minus 8. Just like we do regular division. And then we have to subtract, right? But when we subtract, it's going to change the signs. So we're really saying 2x minus 2x is 0. Negative 7 minus a negative 8 really makes that a plus 8. So that would become a 1. Well, then x doesn't go into 1, and so the way we write this is we say it's a remainder of 1, which is really 1 over x minus 4. So this function is really the same thing as 1 over x minus 4 plus 2. So now we can see how it is shifting, the 1 over x is shifting it 4 units to the right and then up 2. Match the rational function with the appropriate description. Here again is a problem that you're not going to have to do much of because it's really not of the form 1 over x and 1 over x squared in its transformations, but you could get that if you long divided. But you should be able to answer some of this. The y-intercept is negative 1, the x-intercept is 2, the vertical asymptote is x equals 1, or the vertical asymptote is x equals negative 2. Well, we know the vertical asymptote is where it's undefined, where the denominator is 0, and x plus 2 is equal to 0 when x is negative 2. So part D is the true statement. How could I determine the x-intercept? Let's just double check that, and the y-intercept if we wanted to find those. To find the x-intercept, remember we let y equal 0. So we would have x minus 1 over x plus 2 is equal to 0. Well, when we cross multiply, that really gives us that x minus 1 is equal to 0. And so x is equal to 1. So the x-intercept here is 1, 0. What about the y-intercept? That's when we let x equal 0. Right, to find f of 0 would be 0 minus 1 over 0 plus 2, which becomes negative 1 over 2. So the y-intercept is 0, negative 1/2. So we know A, B, and C are not correct, so it has to be D. It says give the equations of any vertical, horizontal, or oblique asymptotes for the graph Oblique is something we're not going to cover in this course. The vertical asymptotes are where it's undefined, right? So the vertical asymptote would be what? Where 2x plus 2 is equal to 0. Or if we solve for that, we would get 2x equals negative 2. Divided by 2, x is equal to negative 1. Now, to find the horizontal asymptote, we really have to find that it's a variation of one of those functions that we talked about. And it is actually. If we rewrite the denominator as really 2 times x plus 1, we can reduce out that common factor. So this is really the same thing as negative 1 over x plus 1. So this is just a reflection and a shifting left of 1 over x. And so the horizontal asymptote did not change in that. So it's the same as the basic function, which is y is equal to 0. The last problem, graph the rational function 4 over x squared plus 1. This one is a special function as well. It's not exactly a direct transformation of what we've talked about. And that's because if you look at the denominator x squared plus 1 and find out where that's equal to 0, then we get that x squared is equal to negative 1. So x would have to be plus or minus the square root of negative 1, which is plus or minus I. So what that tells us is that there's actually no places where it's undefined. So I'll say no values of x are restricted from the domain. So what that would mean is that the domain is all real numbers for this particular function. Well, the only ones that have all real numbers are either A or C. So what you could do is plug in a value just to check. Like if I plug in 0, if I find f of 0, I would get 4 over 0 squared plus 1, which is really 4 over 1 or 4. So I know the point 0, 4 should be on the graph. Well, that happens at A, so that would be the correct graph. Okay, so I believe that concludes all of these problems from the My Math Lab 4.1 and 4.2. If you have any questions, don't hesitate to contact me. Thanks.